For decades, astronomers have believed they understood how objects move through our solar system. Gravity pulls, momentum carries, energy dissipates. Nothing accelerates without a cause. Nothing changes direction without a force. And interstellar objects, especially comets, are supposed to be the most predictable of all. Then 3I Atlas showed up. At first it looked ordinary, a faint object moving fast, coming in from outside the solar system. Astronomers labeled it, logged it, and moved on. Another interstellar visitor. Rare, yes, but explainable. Physics still held. But then the data started coming in, and suddenly, 3I Atlas wasn't just breaking expectations. It was breaking rules. The first red flag wasn't brightness, it wasn't size, it wasn't even speed. It was behavior. 3I Atlas didn't move the way an object like this is supposed to move. Its trajectory didn't smoothly curve under the sun's gravity the way every comet model predicts. Instead, it subtly, but unmistakably, changed. Not once, not randomly, but consistently. Tiny deviations at first, milliseconds of timing differences. Positional offsets so small they could have been dismissed as measurement noise, except they kept happening. And worse, those deviations weren't slowing the object down, they were speeding it up. According to classical physics, an object entering the inner solar system should lose energy. Outgassing creates drag. Solar radiation pressure pushes outward but weakly. Nothing should cause sustained acceleration without visible mass loss. But 3I Atlas was accelerating. Not in bursts, not explosively. Smoothly, quietly, persistently. Astronomers recalculated, then recalibrated, then recalculated again. The numbers didn't change. So they looked for the obvious explanation. Outgassing jets. Comets heat up. Ice turns to gas. Gas shoots out. Newton's third law does the rest. Case closed. Except telescopes saw no plume, no dust tail, no gas cloud, no spectral signatures of water vapor, CO or CO2, strong enough to explain the acceleration. 3I Atlas was behaving like a rocket with no exhaust. That's when the phrase nobody wanted to use started appearing in internal notes. Non-gravitational acceleration. The same phrase that caused chaos during the Oumuamua debates years earlier. The same phrase that forces scientists into uncomfortable territory because it means the object is doing something we don't fully understand. But 3I Atlas made Oumuamua look tame. Unlike earlier interstellar visitors, 3I Atlas didn't just accelerate. It adjusted its path after passing perihelion, the point of closest approach to the sun. That shouldn't happen. By that point, solar influence should dominate. Momentum should carry the object outward on a clean, predictable escape trajectory. Instead, 3I Atlas subtly corrected its course. Not randomly, not chaotically, but efficiently. The corrections minimized energy loss. That's not how debris behaves. That's how systems behave. At this point, observatories around the world quietly reprioritized tracking. The object wasn't publicly labeled a threat, but it was no longer treated as routine. New models were rushed together. Maybe it was a fragment cloud acting like a single body. Maybe it was a hydrogen iceberg sublimating invisibly. Maybe it was composed of exotic ices never observed before. Each explanation required increasingly rare assumptions, and each one failed to fully account for the data. Then came the rotation data. Light curve analysis revealed something even more unsettling. 3I Atlas wasn't tumbling chaotically like most interstellar objects. Its rotation was stable, too stable. Most objects that travel for millions of years between stars get battered by collisions, radiation, and tidal forces. They spin unpredictably, they wobble, they precess. 3I Atlas didn't. Its rotational period remained consistent across observations, despite solar heating, gravitational interactions, and measurable acceleration. That combination alone shouldn't exist. Acceleration without mass loss, trajectory correction without thrust, stability without damping. You can violate one rule and still squeeze out a model. Violating all three at once, that's when physicists start sweating. And then there was the timing. 3I Atlas didn't arrive randomly. Its inbound vector aligned disturbingly well with the solar system's ecliptic plane. Statistically, interstellar objects should arrive from any direction with roughly equal probability. This one didn't. Its path minimized gravitational interference from Jupiter and Saturn, something astronomers usually only see after millions of simulated trajectories. Except nobody simulated this in advance. It arrived already optimized. That doesn't mean intelligence, but it does mean selection. Natural selection or otherwise. As more data accumulated, something else became clear. Our comet models weren't just incomplete, they were irrelevant. Every attempt to force 3I Atlas into known categories produced contradictions. Change one assumption, and three others broke. Adjust density, and acceleration failed. Adjust composition, and thermal behavior collapsed. The object refused to behave like a rock, a snowball, or a debris fragment. So some researchers stopped asking what it was made of and started asking a different question. What kind of object could survive interstellar space, remain structurally stable, regulate its motion, and interact with solar forces without disintegrating? That question has no comfortable answer, because it points toward structures, not rubble. It points toward design constraints, not design intent, not aliens, but engineering-like efficiency emerging from unknown processes. And physics hates unknown processes. As of now, no official paper claims impossibility. Scientists don't use that word lightly. Instead, they say things like inconsistent with current models or requires revision of assumptions. But privately, the sentiment is clearer. If the data holds, and so far it has, then 3I Atlas did something physics does not allow under known conditions. It gained energy without a visible source. It altered trajectory without force signatures. It maintained stability where chaos is expected. That doesn't mean our laws are wrong, but it does mean they're incomplete. And that's the part nobody can ignore. Because interstellar space isn't empty. It's a filter. Anything that reaches us has already survived conditions harsher than anything in our solar system. Radiation, time, collisions, isolation, 3. Atlas didn't just survive, it arrived functional. And if even one object like this exists, then the universe is producing or preserving things we haven't accounted for. Not someday, not theoretically, but right now we're still tracking 3I Atlas. Still measuring, still debating, but one thing is already clear. This wasn't just another visitor, it was a stress test for physics itself. And for the first time in a long time, physics blinked.